Welcome to Ask and Learn.
So for this problem, we're looking for volume, and it's the volume found by rotating a circle around the y-axis. So this is going to give us what is known as a torus, and we'll have x minus the radius squared plus y squared equals r squared. And what we'll end up using is the washer method to solve for x. So when we solve for x, we get that x is equal to r plus or minus the square root of r squared minus y squared. We'll have the positive being the right half and the negative being the left half. So we can use symmetry. We know it'll be symmetrical. So we will integrate from 0 to r and just double it. We know that our radius 1 is going to be the positive and our radius 2 is going to be the negative. So we'll subtract inner from outer, and we get that the volume is equal to 2 times the integral from 0 to r, because we doubled it, remember, and then that's going to be times pi, or of pi times the first radius, which we know to be r plus the square root of r squared minus y squared, and that value is going to be squared, minus, so the outer, r minus the square root of r squared minus y squared, and that value is squared. We integrate with respect to y, and what we end up getting when we simplify is 8 pi r times the integral from 0 to r of r squared minus y squared dy. Then for part B, we're going to make use of solving. When we solve for x and square both sides, we get the equation of a circle. So what we know is that x is representing the right half in quadrants 1 and 4. The integral limits 0 to r, so that's half a circle, which is 1/4. It's half of the half circle, so it's 1/4 of the full circle. So what we can do is replace the integral with the area of a circle, which we know to be pi r squared, and then multiply that by 1/4. So we're going to plug that in here. And what we end up getting is that this is going to be 8 pi r times 1/4 pi r squared. So that'll give us our final answer of 2 pi squared r squared big R.